Hello there, my name is A Petrie. Thank you very much for the opportunity to speak at this international colloquium on the Harappan civilization. I am going to turn my camera off to prevent overlap with my slides as I continue to present. So I would like to introduce the topic that I'm going to be speaking about and also to give you a little bit of an overview. This is a presentation called Living in a Heartland of Villages, Climatic and Landscape Perspectives on the Dynamic Fluvial Landscapes and Settlement Systems of the Indus Civilization. It's effectively a sort of summary presentation of the culmination of a long series of collaborative research projects that have been carried out in parts of northwestern India and actually broader regions. Now, in terms of general overview, we're broadly familiar with the Indus Civilization and the fact that we have settlements distributed over an extremely large area. There's often discussion about the most important Indus cities, for example, that are distributed in various areas, but what's not always mentioned is the fact that these large urban centres are actually situated extremely considerable distances apart, and that the most common type of settlement in the Indus civilization are villages. And people living in these villages are engaging in agriculture and farming. They're making use of a range of domesticated animals and domesticated plants. But rural life is a critical component of Indus lifeways. Now, within the Indus civilization, it's also quite clear that there's considerable diversity in climate and environment, and that equals considerable diversity in terms of the way that people make access to water. So in some regions, such as the large alluvial floodplains of Punjab, we have areas that get direct rainfall, we get areas that benefit from inundation and overbank flooding, and some areas where relatively straightforward canal irrigation are possible. But we also know that in other areas like Gujarat, the collection and capturing of water is actually extremely important, whether that be through large-scale water reservoirs and dam systems such as those seen at Dholavira, or the opportunistic type of water access that has been evidenced by research projects in Gujarat, where it's clear that ancient farmers were making use of interdunal areas to catch water. In the Indus context, we know that there is quite a complex hydrology, and there's actually a long-running debate about the importance of the Ghaggar-Hakra river channel and the possibility that there is many different channels that are in action at different points in time. There have been several attempts to date this channel, and there are still some sort of inconsistencies in the dates that are available. Nonetheless, what is clear is that the Indus civilization underwent a period of deurbanization at the end of the third millennium BC. There was a peak of urban settlement, and then by around 1900 BC, the vast majority of the large-scale settlements had been depopulated or potentially completely abandoned. There was a change in craft production activities and other sorts of things. And there were impact upon health and changes in agricultural practices. And there's a lot of debate about the reasoning for those sorts of transformations that took place. Now, at the core, the way to address these sort of research questions is to investigate the nature of human and environment relationships, to try and work out the types of impact that climate had upon ancient Indus populations and the way that Indus populations lived in their complex landscapes. And to understand human and environment relationships, it's important to use an integrated approach to combine information about weather, hydrology, climate, and also human settlement, and therefore to try and understand the sort of accumulation of information that comes from that integrated approach. In this presentation, I'm going to just give some highlights about the evidence for climate that two important projects have been able to reconstruct, the Land, Water and Settlement and Two Rains projects, and also to give you a little bit of an insight into the types of outcomes that we're coming up with that inform us about the landscape archaeological context in the Indus civilization. Now, it's been long discussed the distribution of rainfall and the impact that rainfall has upon climate zones in the Indus context. it's important to reiterate that the populations of the Indus civilization were actually occupying extremely large areas that were environmentally and climatically diverse. Some areas were, as shown on this particular image, the climate zones in yellow are shown as the areas that are quite arid in terms of climate. The ones in lighter brown are semi-arid, and the ones in slightly darker brown and other colours are temperate. So we can see that Indus populations were living in different types of environmental conditions. It's also been long clear that those environmental conditions are impacted by two very different weather systems. The winter westerly weather system, which drops rain and snow primarily on the Himalayas, but also in the areas to the north and to the west, and the Indian summer monsoon, which falls in a different part of the year and also drops rain on the Himalayas and also areas of central and peninsular India and the subcontinent. Now, again, if we look at the distribution of Indus archaeological sites that are shown on these maps, you can see that some ancient Indus settlements receive direct rainfall in winter, some receive direct rainfall in summer, some receive both, and some receive neither. It's important to think of this in terms of being a complex rainfall and climatic system, one that is fundamentally predictable in terms of there being winter and summer rain, but each one of those rainfall systems is different and distinct. The other important characteristic to remember is that the Indus context is not all about rain per se, but it's also about the groundwater that and the sheet flooding and flow that comes as a result of the rainfall, and that creates a sort of very complex and mobile hydrological system. Now, what appears to be to have occurred is that there was a shift during the Indus urban period, whereby we see by 1900 BC there is a displacement of settlement on the basis of our current knowledge. More settlements to the east in areas of northwestern India and Gujarat, and this seems to broadly coincide with the distribution of the summer rainfall. But there are still many questions about the shift of Indus populations. Was there perhaps increased levels of unpredictability in the winter and summer rainfall? Now, to answer that sort of question, we need further information about weather systems. We need to understand and recognise that the winter rainfall system in and of itself is extremely complex and has a lot of different drivers. The summer rainfall system is similarly complex and has different drivers. And these two rainfall systems are often interconnected, but not strictly so. Analysis of weather over longer periods have demonstrated that there's rainfall variability within individual years, between individual years, and then across decades, centuries, and even millennia. And there's a variety of different seasonal patterns and triggers and different types of disturbances that interfere. So the weather systems are complicated. When it comes to our understanding of the information about climate in the past, we also have a complex story that has come to us through the paleoclimate records that have been reconstructed quite recently. Research that's been undertaken as part of the Land, Water, Settlement and Two Rains project have revealed a number of paleoclimate proxy records that have been obtained from lake beds. And these have shown periods of monsoon weakening at different points over the last 10,000 years. Over at around 8.2 thousand years ago, and also at 4.2 thousand years ago, which is within the Indus urban period. And there's evidence of both weakening, but also rainfall intensification at different points in time. A relatively recent paleoclimate analysis that's been conducted of a paleoclimate record that was originally obtained over 20 years ago has demonstrated that there are actually different dynamics in the summer and winter rainfall patterns over the last 5,000 years. So this record shows some stable isotope results from this core known as 63Ka, which is taken off the coast of Karachi. It demonstrates that the Indian summer monsoon actually decreased gradually, which you can see on the lower curve, from around 4,900, 4,800 BP. So that's 2,800 BC. There was a gradual weakening and then a steep drop at around 4.1 thousand years ago, so around 2,100 BC. This pattern is actually distinct from the pattern that we see with the winter monsoon, which is shown on the top curve. And you can see that there was winter rains were relatively strong up until, say, 4,500 to 4,300 BP, the beginning part of the Indus urban period. And then there was a sharp weakening from around about 4,300 BP, which is around 3,300 BC. And that progressed through the period of the late part of the Indus urban period. Now, that's a record that comes from a coastal area. We also have information that's coming from an upland area in the northern part of the Himalayas. This is a PhD research by a student conducted here at the University of Cambridge. And we can see quite clear evidence for repeated phases of weakening of the Indian summer monsoon from the period around 4,200 BP or 2,200 BC down to around 3,900 BP or 1,900 BC. So it seems like there was multiple phases of extended drought across this extended period. So quite clearly the climate and environment is variable in the Indus context. And from our perspective, it's interesting to try and understand how this impacts upon human settlements. So we know that there is a vast number of Indus and other period sites that are known to have existed in the Indus River Basin. And these sites are primarily known about through extensive surveys that have been conducted in India and Pakistan. Now, we know that these surveys have been conducted and published over the last 20 or 30 years, but it's now clear that there are inaccuracies or possibly imprecision in the location of archaeological sites. Some of these inaccuracies are a result of errors in printing, but often also there are errors that have been produced due to the measuring systems and the coordinate systems that have been used. And this is evident even with the use of GPS devices. So it seems quite clear that there's an important need to reassess the location of archaeological sites. It's important to note also that there are many, many archaeological sites that are not located close to ancient rivers and watercourses. It's also clear that a lot of what we know about the distribution of archaeological sites comes as a result of where the surveys have been conducted rather than where the sites actually were. And it's very clear that there are many, many more sites than we actually know of in the published record. So in an attempt to resolve some of these issues, large-scale surveys have been conducted in areas of northern India, northwest India, and these have been combined with new steps towards analysis in different regions. And I'm just going to mention briefly some outcomes of research in areas of Haryana and Punjab, and also some research that's been conducted on the sites in Cholistan. The work in Haryana and Punjab has been conducted as part of the Land, Water Settlement and Two Rains projects, which conducted large-scale surveys and combined those with excavations between 2008 and 2020. One of the things that we were keen to do was to identify the location of ancient rivers and watercourses in this area. And we've attempted to trace and reconstruct the complexities of the ancient rivers of Haryana and Punjab within India. What's clear is that although there is clearly one very large paleo channel across the middle part of this plain, there are also many, many other paleo channels in this area. And it's now become very clear that it's important to try and reconstruct the chronology of these channels and also to try and understand the association of archaeological site distribution across this complex landscape. One thing that's proved to be very, very important to do this is to make use of historical maps that have evidence for mound features on them. Archaeological sites were actually being recorded up to 100 years ago by survey teams of the Survey of India, and systematic identification of features on these maps and then identification of these features on the ground through archaeological survey is revealing new information to us about the changing settlement systems of the Indus civilization. What we can now say is that in the earlier period, before the development of Indus urban settlements, there was small village settlements quite widely distributed across the plains of northwestern India. Some of these settlements were located in proximity to the larger paleochannels. Some of them were located in proximity to smaller paleochannels, and some of them do not appear to be associated with any particular watercourse. With the development and growth of larger centres like Rakhigarhi and Banavali, there appears to be some level of depopulation in certain parts of the landscape and a concentration of settlement along some of the water channels. But what's interesting, again, is that there's not a specific focus of settlement along all the river channels, and also some of the settlements appear to be located in areas that are isolated from known water channels as well. We also have evidence for the nature of change that occurred after the period of Indus urbanism. Settlements like Rakhigarhi were apparently abandoned, and populations appear to have redistributed into different parts of the landscape, many of which seem to be shifting further to the east of the area that we've surveyed. But there's still much to do in terms of understanding the distribution of settlement across these larger landscapes. What's really important is that it's important not to just conduct survey in isolation, but also to conduct integrated survey work that considers the nature of the material culture change over time, and to try and ensure that we're not making mistakes in terms of the interpretation of the material that we're identifying from the survey. And we've attempted this by excavating a number of sites in the area adjacent to Rakhigarhi, including Lohari Rago, Masudpur 1 and Masudpur 7. And our excavations have focused on horizontal and vertical excavations and attempting to try and get paleoclimate information and to try and understand the way that populations live within these particular landscapes, the type of crops that they use, and the types of pottery that they're using, the relationship between this sort of pottery assemblages that we see in rural settlements and surrounding areas. And one of the things that we're pushing towards is to try and use agent-based modelling to reconstruct different types of landscapes and reconstruct the outputs that come from growing certain crops in certain environments. Now, just to sort of highlight another piece of work that we've done looking at the area of Cholistan, we've reassessed the survey data that was collected by Rafiq Mughal and his colleagues in the 1970s and 1990s in this very, very important area of Cholistan in the southern part of Punjab. A careful reassessment of the data and using statistical techniques have demonstrated that these sites are particularly dense in certain periods of time, but actually there's relatively limited numbers of settlements that appear to be occupied in consecutive periods. So this suggests that there was a considerable degree of instability in the settlement system of Cholistan. And the reconstruction perhaps suggests that people were moving relatively regularly in this quite sensitive landscape quite close to the edge of the desert and engaging in displacement of settlement. Now, using remote sensing imagery and satellite imagery that's now available quite widely, it's been possible to try and identify the archaeological signatures of, the signatures of archaeological sites that can be detected remotely, and therefore to use those signatures to build up new maps that show the distribution of archaeological sites and allow us to cross-check the locations of sites and their levels of preservation. Now, this is research that was published in 2020, and it's demonstrated that many of the archaeological sites that were identified in the 1970s are still in existence, and also significant numbers of them are under threat, either through the expansion of the desert or the expansion of agriculture. Now, what's interesting is that the distribution of sites does seem to conform to quite specific types of landscape contexts. And it's now we're in a situation where it's possible to conduct new and renewed research to try and really understand the changing settlement and dynamic settlement systems in these environments. Now, this has been an extremely quick presentation, and I appreciate that everything could be presented in more detail. I would like to highlight the fact that this is the result of collaborative research between University of Cambridge and Banaras Hindu University, especially my colleague, Professor Ravindranath Singh, as part of the Land, Water, Settlement and Two Rains projects, which have run over the last 15 years or so. But the work is being continued as part of the MASA project, which is a collaborative research endeavour based in Cambridge, but also involving colleagues at different universities within India and also Pakistan. And we're setting out to really attempt to document all of the archaeological sites that we can identify across the Indus River basin and looking at settlement distribution across all periods, with the aim of trying to integrate what we know about climate and weather systems and what we know about hydrology and landscapes with what we know about the human settlement systems in these environments. Thank you very much.